Hey everybody, we should be live. Let me know if there's any video or audio issues. Frame rate dropping, can't hear me. Stuff on the screen is too small. I'll go ahead and get my zoom a little higher. And gotta plug the Patreon in the chat, because that's what we're doing now. We're doing Patreon. Thanks to everybody that is already on the Patreon. I was super encouraged by the number of people we had joining that right away. So that's awesome. So started this early. We're 5 minutes early. So for anybody going back to the playback and the archival, and this is now what you're getting to watch, you might want to skip ahead a couple minutes. We'll get there. And now I got to do the Twitter action here. Good to be doing this again. Went heads down for forever, trying all sorts of stuff, which I'd be happy to talk about, by the way, if anybody wants to ask any questions about the development process for the Beaker 1.0 release, which I'm sure you know is a varied story. And there's, as I've been talking about, there's some stuff we didn't ship, so I'd be happy to talk more about that. Hey, Philip, really good to see you. You know what I need to figure out is if I can get like a Patreon integration into the YouTube chat. So you can get like a little heart next to your name or something. That'd be really sweet. I should move this chat somewhere closer to my eye line. Let's see. Let's pop the chat out. I'm just going to stick this on my screen. So hopefully that's not kind of gross. And so that looks like that. It takes a fair amount of screen real estate. Yeah, I hope y'all don't mind that, but I just don't want to keep on looking over to the side. YouTube's got their own subservice, huh? I suppose that would be what they'd do. Can't begrudge them that. Is the audio okay, Philip? Can you hear me okay, even when I'm kind of talking low? I guess while we're waiting for people to show up, I'll go ahead and kick open Uplink, which we've been sort of not telling everything about. Hey, Carissa. Glad you can hear me, and thanks for joining. Okay, so, yeah, we've been teasing this Uplink thing, not really talking about what it is, which hopefully hasn't built it up too much. It's a pretty straightforward piece of software. We're just going to try to fix the story around creating and sharing file archives, something which is pretty core to the entire idea of the Hypercore protocol, core to the idea of DAT back in the day. Just sort of occurred to us, you know, it would be really good to get this part working really well, because Beaker is great for the peer-to-peer websites, but just sharing files, that seems like an aspect that gets a little bit underserved by Beaker. So wouldn't it be nice if we just had a tool that felt like a kind of a Dropbox or a Google Cloud, and it's totally peer-to-peer. And so we forked the code base of Beaker and have just sort of progressively realigned it into this new thing, which is why some of this will look familiar. And I'll jump over to one of the hyperdrives I got here, and there you have it, the little Files Explorer. And it's already diverged quite a bit from Beaker in terms of the features. We've got things like those little circles over on this next to the files there. They still have zoom? Do have zoom. These little circles here show whether or not it's locally cached, which is a handy thing. We got some nice bandwidth usage stats over here and a way to see the current connections. And there are pieces of this that are a little bit broken because I'm in the middle of rewriting some of the internals, and that's probably what I'll be working on the stream once we get to the point that we're working. But just to start things off, I'm just going to show a little bit about where it's at, and the chat is totally open to ask any questions you want about this, about Beaker, about what happened in the dev cycle about Beaker, which is something I've been talking about a little bit, those features, those social features that we wrote and then threw away. I'd be happy to talk more about what the heck happened there, because that was a whole thing. So we'll get into the code in a little bit, but for now, just chat is wide open. Feel free to ask me about anything. But here is, yeah, the basis of this guy. Let me grab the link to my profile drive that I have from Beaker so that we have a more interesting thing to look at. So I'll copy this link and we'll go there. Okay, so now Uplink is pulling this off the network, and some of the data was already cached, which is, you know, good, helped it load a little faster. And I assume, who knows exactly how much I've broken things, because like I said, I've been rewriting a couple of the core pieces, and I'll show why in a second, because it's actually pretty fun why. Yeah, Carissa says she's glad we could finally deprecate desktop. Not trying to crowd it out or anything, but I imagine it'll be nice to be able to say, hey, this is being actively developed. I don't know how bad my lag is on the chat here, so if I'm light years behind, sorry about that. Okay, so anyway. Yeah, so I don't know how much I've broken. I feel like I should be seeing some bandwidth transmission here, so maybe that got broken. Let's find out. Let's try jumping over to like an image here. And let's try loading this GIF, and yeah, see, that's a bug I gotta work on. So let's refresh. No, actually, it just looks like I don't have any peer connections. So I'm working entirely off of cache. Now, why wouldn't I have any peer connections? Let's try loading somebody else's drive up. Block not available from peers. Interesting. We're just getting no connectivity at all. Well, let's make sure my hyperspace is up to date. While we're waiting for that, I will jump over to Twitter, make sure I'm not missing anything over here. Okay. I should have checked the version to see if we actually changed. I'm confused. Is it only possible to find out about what Uplink is by paying for the Patreon? Wouldn't sharing info about it bring in more people to support the Patreon? That would make sense. We will tell everybody about this. We just thought it would be kind of funny to add an air of mystique. Now, well, we're gonna. I'm actually somewhat debating right now how much to do privately in the Patreon versus how much to do publicly. Like, I put out a blog post on the Patreon that was for patrons only. And part of me is like, I want to make sure that subscribing to the Patreon gets you something unique. But on the other hand, making those things public would also get more eyeballs onto what we're doing, would get more eyeballs on the Patreon. So I'm trying to balance that out, and I'll probably do a hybrid there. Uplink's not going to stay secret. It's just we wanted to get to the point. Yeah, and this stream is public. Yeah, we're not really holding that strong to the secrecy here. It was just a fun way to get things going. Plus, I love Uplink. I'm super excited about Uplink, but this isn't exactly something to get super, mysterious about. And speaking of not getting too too precious about it. Let's see if I can get this thing to actually load a hyperdrive off the network, or if we've got bugs. Yeah, we might do some early access stuff. Okay, interesting. Why am I not getting connections? Huh. That's very odd. It's not even trying. It's just bailing out right away. I wonder if, surely our network isn't down. That'd be a shame. Let's try another drive. Well, that one worked. Wait, did it work, or is that just the cache? Yeah, early access is something that we'll probably consider. Next, I think people will support the Patreon because they want to support your projects, blogs, should be public, and the rewards should be early access to betas. I think that's a good call. That's probably what we ought to do. Just always want to make sure everybody's getting something as good as they can get out of contributing, because we appreciate that a ton, and you know, just want to be sure that we're giving y'all something for doing it. Boy, our internet, our networking is just not working. All right. Huh. Well, let's try nuking all the temporary hyperspace data. Give it the old, you know, nuke and start over. See if that's what's going on. Applications, port, uplink. Gotta give it the RF. Let's zoom that stuff a little bit. Okay, so let's try starting hyperspace again, and then, ooh, too big. Let's try starting uplink again. Maybe uplink is actually out of date. That might be the case. Demo gods are unkind. Okay. I'll take that. I'll take that comparison. This is I'm laughing about I can't carry. Is it use L? I don't know how to say his last name, but I know who you're talking about, and I will absolutely take that. This is literally the first time I've ever been able to grow any meaningful facial hair, and so I'm doing it. It's mustache time for Paul. Never thought I'd be the mustache wearing type, but here I am. Okay, I'm gonna try running a burn them all over here. One fun thing is that Uplink doesn't use SQLite internally anymore, which means that the burn them all should be a lot faster, which is great. In fact, I don't know if we have any, other than Hyperspace, I don't think we have any modules that are native modules anymore. Just the Hyperstack. And that's actually really exciting. The reason that we're not using SQLite anymore is that internally I'm now using Hyper-B, which is the sort of key value database on top of the Hypercore protocol that Matthias recently authored. So Hyper-B is, it's named that because it's a B tree, which is a kind of data structure that a lot of key value databases will use. In fact, a lot of, as I understand it, a lot of SQL databases will use B trees as well, for instance, on all their secondary indexes. And the thing that's interesting, so you got Hyper-B and you got Hyperdrive, right? And if you really know the details, Hyperdrive is built on top of Hypertry, but let's not worry about that. We got Hyper-B and Hyperdrive. And the Hyper-B differs in one really specific way from Hyperdrive, and that is that it is able to do range reads. So say, list all the keys and do them in order efficiently over the network. So I can say we got let's say a key range of A to M, right? A to Z would be the full thing, let's say, but we want to do just A to M. We can efficiently over the network do a list call, create read stream, whatever, and say go from greater than or equal to A, less than or equal to M, and that will give us just those keys efficiently over the network. That's a really, really important property for a key value database. In Hyperdrive, you can't do that. You can't say, give me just the file names from A to M. You actually have to get all of the files within a folder, all their file names, and then ask, then pull out just that subset. And because we're going to be using the Hyper network as a database, you want basically any query that you're going to be running a lot, you want that to be as efficient as possible. You want it to feel as close to a non-networked database as possible. And so Hyper-B is a much better basis for basically acting as a database than Hyperdrive was historically. And in sort of to celebrate that, got rid of all the SQLite usage inside of Uplink, and are now just using Hyper-B. And I'll talk about that talk more about that in a second. But I'm getting a question here, which is, can we host our own website and a Raspberry Pi, which is always plugged in, rather than our main PC? Novigrad, I think maybe we talked on Twitter or somewhere else about this, but I'll go ahead and share one of the tools you can use to accomplish that, and that is Homebase. And Homebase should be getting, it's a pretty stable piece of software. I don't know how much more we're going to be investing in it in the near term, but it gives you a nice starting point for what you're looking for there. Ranger Mauve, who is in the community, is talking about getting some tooling around having Beaker be able to, or any, hyperspace application being able to communicate with something like Homebase and say, hey, host this for me, hey, stop hosting that thing, etc. So kind of remote management. So it may develop along those lines, and we're planning on having a call about that in the near future. But I just did a rebuild here, so let's take a look. See if that is finally going to make this thing work. And if not, that is a darn shame. I guess I broke something. Okay. Is there anything in the log indicating what's going on there? No. Well, maybe maybe we'll end up debugging that in our spare time here. Even creating a hyperdrive just failed. Oh boy, I broke it all. Hyperspace.create. That's actually, I knew that I broke that. Well, we know exactly what I'm going to be working on the stream, so that's great. Okay, so before we do that, I want to show one other fun thing that's going on here. I mentioned that we're excuse me. I mentioned that we are using Hyper-B for the database, and one of the kind of fun things, this isn't the purpose of Uplink quite yet, but one of the things it can do now is actually render a Hyper-B in the same interface that we're looking at here. So let's real quick. I'm gonna go to the command line, and I'm gonna dump out the URL of my internal Hyper-B. Application support uplink hyper.json. Okay, there it is. Copy that. And if the demo gods are willing, there it goes. So this isn't anything particularly amazing to look at, but this is the Hyper-B database that is being internally used by my instance of Uplink to store settings. It also stores things like the hyperdrives I've saved, which will come into play once I unbreak creating a hyperdrive. But if we want to kind of see how that plays, let's see if I've broken the preferences. I haven't. Great. So I'm going to force this thing into dark mode, which is not super well developed. And then very well, not well developed. So that's hard to see. But if you look right there, settings, app theme, just changed to dark. Why don't I change it back to light, and we'll be able to see that better. Oh, dark mode. Okay, then take it back, and there we go. So now you can see that setting being recorded there as light. So internally, we're using this Hyper-B. And one of the reasons that I broke everything recently was basically rewriting the internals of Uplink from its fork of Beaker to be data structure agnostic. Beaker is... poor dark mode. Yeah, we'll get there. Just do it later. But Beaker is currently only understands hyperdrives. We wanted to eventually understand other kinds of hypercore data structures, but right now it only understands hyperdrives. And so Uplink, I got started on creating that sort of generic agnosticism where it can handle more than one kind of hypercore structure. And so that is the changes I was making recently, which is why everything broke. And probably on the stream today, I'll be unbreaking all those different pieces. But the fun thing is here that there you have it. I'm able to load up a Hyper-V structure in the front end of this thing. And like I said, I don't think we're going to spend a whole lot of time on Hyper-V support at the outset. Uplink is really focused. We're all about this right now because we just overextended ourselves so badly with Beaker in that dev cycle. We have gotten very rigorous about, let's say, really, really focused on just doing what we know we can do, kind of do one thing well, and make sure we're delivering that to people. You know, no half measures, no kind of broken thing. Let's make sure that the one task that an application is meant to solve does it well. For Beaker, that's peer-to-peer websites, and for Uplink, that's going to be file sharing. And ideally, private file sharing. So we're kind of thinking sharing it amongst, 1, 2, 3 to 5 people, amongst small groups. You should be able to use it for publishing file archives as well, but that's not going to be our focus. Our focus is going to be on privately sharing files with friends, family, and offices. I got a question here. What about using Hyper as a YouTube replacement? Assuming you have reliable means to share a video file, could streaming capabilities be added? Perhaps pair it with encoding. Philip replied, I think video streaming has already been demonstrated at some point, either using DAT or Hyper. So you can do that. The biggest limiter is a real bummer. The biggest limiter is a bug in Electron. You currently are... this is something that's been a problem for a while, where video files and audio files using the video tag and the audio tag don't play off of the Hypercore protocol API. So the Hyper URLs, if you're linking to a video or audio, it doesn't play. So I had to jump into the Electron source code and then into the Chromium source code to try to fix this. And I put together a patch. It took months. We finally got it shepherded through. It involved me opening up a pull request on the Chromium itself and them going, what the heck is this? No. So now Electron has to manually apply a .patch file. Unfortunately, I missed a detail. So you can now play video files inside of Beaker. They will play, but you can't seek. You have to play straight through. You can't jump to a position in the timeline. It's such a stupid thing that I missed. But all I was testing was, does the video file play? It plays. PR ready. So that stupid PR that I took months and months to get merged doesn't have the ability to seek around. Oh, it's life in the NFL, I guess. So now we're, at some point, I guess we're going to get around to fixing that. In the context of Uplink, we actually decided to solve this using a total hack. Uplink, conveniently for us as the developers, is not a generalized web browser. It's a viewer for Hypercore, for hyperspace data structures. So you can visit hyperdrives and Hyper-Vs, and doesn't currently, and I don't think it will, doesn't currently display HTML. So when we have a video file inside of Uplink, what we actually do is we have a local hosted HTTP server that we're streaming the file off of. And that local hosted HTTP server is being run by Uplink internally, and it talks to the Hyper network. It's literally a workaround to this one specific Electron bug. That's the deal right now. Now, if you're looking inside of the Beaker ecosystem, I think you could probably find a way around this problem by creating a video player that uses JavaScript to read the video chunks and pipe that into the video player. It'd be really hard work, though, so it's a really kind of an unfortunate situation. Not happy about it, because, yeah, a YouTube replacement would be a pretty cool thing to do with P2P tech, and for such a dumb reason to be in the way, that's a shame. So that's the sitch there. Maybe more information than you wanted to know, but that's the deal. Okay, now with that, I think it's time to start unbreaking some of Uplink. So if it sounds good to you, I apologize, I'm letting myself get distracted by the comment stream. If it sounds good to y'all, I'm going to start breaking into some code. I'll continue to answer your questions, so feel free to ask me anything you want in the chat. But I'm just going to dig in, and I'll probably start by giving an overview of some of the details about how this is structured internally. If you're building your own applications on top of Hyperspace, which is the kind of the nice put-together stack for building applications on the Hypercore protocol, you might find this interesting, might see some interesting pointers. I'll start from kind of how it starts and go through all the pieces, and then we'll start fixing things up. So just to address these questions in the chat real quick, is a beaker headless a thing? Not currently. I guess it sort of depends on what you want the headless beaker to do. If you're looking for just like command line tools to be able to access hyper content, ask around in the community. Jump into our Discord, ask in general, see who has what there. I think we could probably stand to do a little bit of work on that tooling right now, and I don't know if anybody's put together something custom that I just haven't noticed recently. Andrew Osheroff has put together something called Hypercopy, which is a nice little command line tool for kind of quickly reading and or, downloading and exporting files off of the file system. It's meant to be sort of a quick and dirty tool, but it's a nice one to have. But I think a kind of a Swiss Army knife command line tool for the Hyperstack would be a good idea. We just haven't gotten around to that since Hyper moved away from DAT, and the DAT command line has been left a little bit. So yeah, Philip, if you have more specific questions about a headless beaker, you could ask me. There's also Ranger Mauve made something that was like I think he called WebRun. Check out WebRun. That was a pretty cool project too. So yes, of course, happy to give the honesty. Yeah, it's just me here, so I'll be real about what's going on. What about building hyper apps with Qt or native stuff? Yeah, you could do that. You should be able to do it. The one thing that you're going to need for any hyper application you want to build is some version of the Hypercore protocol stack running, which probably should be Hyperspace. Let me share in the link real quick. Share in the chat real quick a link to Hyperspace. Okay, so that's Hyperspace there. Is that the right link? Yeah. And Hyperspace is a node program that is supposed to run as a daemon. So in the background, it's kind of like the equivalent of having, if you were using like Postgre or MySQL or something like that, or Redis, you would run the database process somewhere and then your application would talk to it. It's the same story here. And so Uplink and Beaker, for example, both bring a copy of Hyperspace, and if Hyperspace isn't running when they start, they go ahead and spawn that daemon. The way that's designed should be that as long as there's any client to Hyperspace, it'll keep running, I believe is the situation. I believe. Actually, don't quote me on that. But that's the tool you want to use. So if you are wanting to use Qt or something native, you would need a version of Hyperspace that you can execute from that environment. And with Electron, Node comes along with it, so whenever we need to spawn up Hyperspace, we actually are taking the Electron binary and pointing it at the Hyperspace scripts, and that spawns a Node process, the Node process that's bundled with Electron. That's how that works. If you're not using something that comes with Node, you're going to need to ship Node basically at this stage because we don't have any native code versions yet. There are tools out there for bundling Node JavaScript applications into binaries. I don't know how good they are right now, but you could definitely look into that as a way to solve that problem if you're not using Electron. So that's the sitch there. Let me know if you have any more questions about that. And okay, so let's dive into some of this code here. I'm gonna, like I said, give a little bit of an overview about how all this works internally, and then I'm gonna start debugging some of these problems we got. And just for safety, let's see one more time if maybe it's gonna start behaving. Copy this link location and open it up. Still not working. The fact that that bombs out immediately is telling me, I would bet, we're just not on the network at all. So I gotta find out why we're not getting on the network. For all I know, the hyper network is down, but I doubt it. And there's a pretty simple way to find out. Why don't we open up, not you. Why don't we open up this little app called Beaker and see if it's able to connect to any websites here. So that's my local one. Let me find, This may just be cached, so this may not be the best test. It seems to be working. And I got peers. So this is a problem with Uplink, not with the hyperspace network, which is good to hear. We now know the scope of the bug, and it is local. Okay, so let's dive into some code here. This is pretty zoomed in. I'm going to zoom out one more level to get more screen real estate. Let me know if this is too hard to read. I'm happy to zoom it back in a little bit more. Let's go ahead and close down all these buffers and jump into the code structure. So if you've looked at the Beaker code structure, this will be a little bit familiar because, again, I forked Uplink from Beaker. Gradually, it's becoming less and less like Beaker, but there's still a few vestigial limbs. And so let's start with the daemon code. This daemon code is really pretty straightforward. It's now just 150 lines. Its entire purpose is to, on setup, try to connect to the daemon using the hyperspace client code right there. So it'll try to connect, and if that fails, it's going to go into the daemon launch process. It's going to try to spawn its own copy of the daemon. That's what this little bit of code is right here, which is a sort of a unique to Electron piece of code here. I'm basically getting the path of the Electron exe, or the application exe, and then calling the daemon by the daemon path, specifying a storage directory, etc. And then using some Electron things to say, just run the node process and don't use the ASR packing format, which is a whole thing that Electron does that we don't need in this case. And then we have this handle to the daemon process, which we can watch for information. For instance, if it logs anything, we can pipe that into our local logs. And we can also watch for that thing to die on us so that we can potentially deal with the loss of the daemon, restart it, things like that. So that's pretty much what the daemon control file is for. And then pretty much everything that everybody else cares about in the code base is this one right here, get client. Right? So once we're able to get the client, we can start to use it for things. Now, the interesting stuff is the structures.js. I called it structures. I needed a generic word for basically all Hypercore data structures. So hyperdrives, hyper-Bs, hypercores, anything that you can publish on the Hypercore protocol. The hyperstructure.js is designed within Uplink to be able to load it up and get you the right interface for it if it understands the data type. So that's what this file is here. And so anytime that I want to, that somebody hands me a hyper URL in Uplink, it's going to call this get function. And it's going to look to see if it's already loaded, and if it's not, it's going to load the hyperstructure class with the key, call the load function, cache it, and that's that, right? So all the magic is happening right here, and this is pretty simple, right? It's just 111 lines, this entire thing. So, in our constructor, we take the key string, hold on to that, and we've got attributes for the type, for the header block, and for an API to the Hypercore data structure. And on the load, if this is the first time, we will, first of all, get the daemon client. So this is a client API to Hyperspace. We're going to instantiate a core store, and a core store is an interface to basically the data storage for hypercores, right? So I'm getting a handle to be able to load hypercores. And I ask for it to give me the hypercore for the key of the data structure we're working with, right? So all Hypercore data structures are built on these hypercores that are logs of data. And I'm grabbing the Hypercore API because I want to read the very first block inside of a Hypercore. That's our step one, because Hypercore now is a self-describing system. The first block on a Hypercore log is a little header block that says what type of Hypercore data structure you're about to be interacting with. And that's good because that means that we can look at that block, detect what kind of data structure it is, and load the correct handling code. So there are two kinds that we handle currently, hyperdrives and hyper-Bs. So the first thing we're going to look for is to see if this thing is a hyperdrive. And internally, hyperdrive uses something called hypertry. We don't need to worry about that. It's just what type we're going to be looking for. So that's what we grab first. And if that decodes successfully, if our hypertry header decodes successfully and we see that it's a hypertry, and if the subtype doesn't tell us it's not a hyperdrive, then we stick with hyperdrive. And then we know we are looking at a hyperdrive, and that's that. Okay? So right here, detecting if it's a hyperdrive. If that doesn't work, and Matthias is telling me there's a more efficient way to handle this, but I'm doing it with this double try catch bit. And I've got some half-written comment there, so whatever. So then we try again with the Hyper-B header this time, and if that works, we know, hey, it's a Hyper-B. Now that's actually not the right thinking, is it? Because it could parse successfully. So I actually need to tweak this. I think what I need to do is I need to have something similar to this right there. Is this type a Hyper-B? And I believe it's called protocol in the case of the Hyper-B header. Why don't we do a quick console.log and see if I can make this code a little more correct. See, this is the advantage of sitting and parsing through all your code. You find little mistakes like this. Okay, so let's load up that Hyper-B again, and we should see in the logs. Yeah, I was totally right. There's a little string inside the header block of a Hyper-B called the protocol, which will say Hyper-B. If it doesn't say Hyper-B, then we don't have a Hyper-B. So we need to do that check. And so we're going to do, if not this.header type, nope, protocol. It's not equal Hyper-B, and we're going to bounce. And that should be more correct now. So now if something showed up that wasn't a Hyper-B or a hyperdrive, we wouldn't incorrectly see it as a Hyper-B, which is what would have happened there. Fixing that code. Okay. So that is the detection part of it right there, right? So we have this Hypercore that we loaded up, we read the first block, we figure out what we're looking at, and then we throw away the Hypercore. Well, we hold on to the Hypercore actually, because we may want to use it. But the next step is to load up the API that's specific to that Hypercore data structure. And I'm getting pinged, so let me make sure I'm not missing something important here. Nah, okay. Okay, so yeah, now we're going to load up an API that's specific to the data structure type. If it's a hyperdrive, we're going to load up the hyperdrive API. If it's a Hyper-B, we're going to load up the Hyper-B API. And that gets stored in the this.api for our class here. So, right, we got the type, which will be hyperdrive or Hyper-B or Hypercore. I guess actually unknown would be, yeah. Then it's going to be the header block that we should just hold on to, because who knows, that may be handy. And then this API object, which we're instantiating here to be specific to which kind of thing we're working with. And once that API says it's ready, we are all set. And we can start using this data structure. So that's our sort of generic hyper data structure loading code. Let's make sure that's all working still. Looks like it. Okay, so that's that part of it. Now the way that I'm actually interacting with these data structures sort of depends on whether or not I'm in the background process or in the foreground process. Electron applications are constructed almost like a client-server architecture, where you have what's called the background process, which is sort of like the server, and then each window, or even actually sort of more specifically JavaScript context that gets loaded onto the page is like its own client, sort of like its own tab inside of a web browser. And so this whole UI is in the what you call a renderer process. It's like the client side, and then the background process is hidden away. That's where all of the sort of persistent state and computation is living. So very similar to a traditional web application, which is nice because that's kind of what I know how to do. So whenever I want to interact with the back end to talk to these data structures, I use a little bit ago that I wrote this code, so let me refresh my memory by jumping into some of my front-end code here. But I believe that I have a little handy tool, hyperstruct. And I'm gonna, do I have the URL? Yep. So let's move this down. I had to do some sort of equivalent code on the client side. Let's zoom it in a little. Hyperstruct.get, and now I have basically a JavaScript proxy. Not going to explain JavaScript proxies. But basically, they're like magical JavaScript objects. And anytime that I reference any attribute inside of this B variable here, it's actually, unless it's a couple of specific things like the URL, that's an actual real normal attribute. But most of the time, what it's actually going to do is create a function automatically anytime I access a property, and that function will call out to the back end of Uplink and call the correct function that's actually on the .api object here, right? So I've got this handle to right here, and if I do b dot, let's do b dot get type. I think that's right. Except it's only one exclamation point. There you go. With that, we get the correct value, uplink/userdb. And don't worry too much about that exclamation type convention. I'm not sure that's going to stick. That's just something I'm toying with right now. But the interesting thing is that b.get worked correctly. And what happened there is that when I call b.get, like I was saying, it actually doesn't... b.get is not an actual function on the b object. What happens is that the proxy gets invoked, and it generates this function right here, which is just sending the function call I'm making, turning it into some JSON, sending it into the backend, and then it's calling the exact same function that I just called on this.api. And so if we jump over to the code, we can see this is pretty straightforward. It's the hyperspace here, and it's call promise. That's what ends up getting called. The URL of the hyperstructure we're calling against, what method we're trying to call, and a list of arguments. It calls that structures.get to get the struct, grabs the API, looks for the promises one first. That's a hyperdrive specific thing, don't worry about that. Calls the API method and returns. That's it. And as a result, we have this highly generic system for interacting with both Hyper-Bs and hyperdrives. Nice and simple. And that was what I was working on right when I broke everything. So hopefully it only broke everything because it changed a lot of the internals, not because the code is broken, but we'll find out. I guess to kind of add some completion to this, even though I guess until I fix the hyperdrive loading, we're not going to be able to try out the hyperdrive thing. The only reason this Hyper-B is working right now is because it's a local data structure. So why don't we first fix the creation flow for making a new hyperdrive? And the reason that broke is because I haven't replaced the create hyperdrive code yet. So let's get started with that. Now, the way this is all structured internally is that there's actually, because this inherits from Beaker, we actually have a shell window, which is, all right, I'm going to use this as a placeholder. So if I go right here and I do that, all right, everything that's not the DevTools, it's this bar across the top and this sidebar, that's the shell window right there. And everything that's underneath the DevTools right now, that's like a page. So it's kind of, you could think of this as being kind of like Beaker, but this is the browser shell right here, and this is the current page. And if I navigate around, you can see that that's the part that swaps around, right? Did it that way in case we want to load untrusted code into the system. Having this sort of two-tiered setup on the front end allows this area to be low permissions and this area to be high permissions. And the code that we are interested in is this sidebar code right here, because when I click that new hyperdrive button, it's running some code that's not currently working. Okay. So hit me up in the chat real quick just to make sure you're all with me. It's gotten quiet, and I assume that's because y'all are just listening, or not. But just let me know, make sure we still got a good connection here. And while we do that, I'm going to jump over to the shell code, which is under FG, shell window. All right, Philip, thanks for joining. Catch you on the next one. How much time do I got? It's 2:30. I got plenty of time. All right, so I'm going to jump over the sidebar here. And I'm going to look at the code for new hyperdrive, which is somewhere around here. Right there. Okay, glad to hear, J-Boob. Okay, so I've got this function right here. Await hyperspace.create, and then I'm passing in a string saying make it a hyperdrive. That seems like the right signature. Keep it generic. I could do like create hyperdrive, create hyper-B, you know, do different methods for the different data structures. because I don't actually need a whole lot of genericness on this. It's not like I plan on having a whole lot of different Hypercore-based data structures here. I don't know if it really matters a whole lot, though, so I'm going to stick with that generic thing. And so here's our background piece, and we just need to write this create function. So type, and all of these RPCs have a manifest that I need to implement, so we'll go ahead and add create. And this should be pretty straightforward, actually. It should just be a call out to a hyperstructs.create function, then returning the result, and that's where all the action will be. Alrighty, so now over in this zone, let's write our create function. Creating is pretty simple, actually. It's similar to loading. It's just that rather than passing in a key ahead of time, you just say, I don't have a key yet. And it'll go ahead and create a new key for you, create a new hyperstructure for you. So, now, just need to look at this code and figure out what the best way to do this is. Might be the action is to write... Oh, what's the best way to do this? Could do a create function inside of here, so I instantiate a new hyperstructure called create. That'll run some code similar to this. Yeah, I think that's the way to do it. So we'll do async create to do, and then over here we're going to do struct equals new hyperstructure and no keyster. That's intentionally null. Now let's see. Does it ever... Okay, so we'll need to set the keyster. Keyster! Alright. We'll pass the type into create. And once that's done, all the attributes should be properly filled, meaning the header, the type, and the API will be filled. So then we just need to cache the thing, just like in the getter, using the struct.keyster. And then we'll return probably the struct itself. And so then over in the API over here, we'll want to modify this because we can't pass that object back over the network, so I'm just going to pass back the URL, and that'll be that. CSS. I've seen similar apps built on IPFS. Is the primary benefit of Hyper the versioning, or have recent changes also made it more performant all around than IPFS? I can't, to be honest, draw a super direct comparison in terms of performance or capability benefits or anything like that, mainly because both of the technologies move pretty quickly. And so something that may be true at one moment may not be true long for another moment. Frankly, if I were pressed, I think the thing I would say that's different is just different approaches, different code styles, different API styles. IPFS is a highly generic design. It's a neat design. It just has a different philosophy. With IPFS, the basic idea is they're going to use content hashed data as their primary primitive, right? So they're going to be using the idea of generating this kind of static thumbprint, the content hash. I suppose they probably use something like a SHA-512 or something like that to produce a content identifier for a static piece of information. That's their core piece. Everything that they do is built off of that. And so then if you have, when you're creating data structures, you're creating what they call the Merkle DAG, which is sort of a giant data structure where every time you create a new piece of information in IPFS, it gets its fixed ID that should never change. And then when something points to it, it's creating a graph pointer to it. So that's where the DAG comes from, directed acyclic graph. And I'm in the weeds now, so let me bring it back. Point about this is that IPFS starts from that really kind of basic primitive. It's a highly technical idea and builds everything on top of that. And so for dynamic data in IPFS, they'll create a public key and they'll point to one of the IPFS hashes. There's static hashes, and that's how they do data that changes over time. That's the basic premise. Now, if I had to kind of contrast that to what Hypercore does, really the IPFS approach is just more generic. A content hash design can be used to kind of construct any sort of data structure you like. including a log similar to what we do with the Hypercore protocol. So what's different about the Hypercore protocol is that it doesn't start from this idea of just the individual chunks of data with their content hashes. Instead, Hypercore starts at a slightly higher level. In Hypercore, you are always working with a log of data, every time. The Hypercore is the lowest level piece in the system, and it's a higher level abstraction than the IPFS chunk of data. It is a log. And the logs have a public key as their address. And so the everything that we build on top of Hypercore is built on top of these logs, similar in a way to Git. And so whenever you build something on top of Hypercore, what you're doing is you're building it on top of this log to create a new data structure on top. I could speculate about some of the benefits of taking the Hypercore approach versus the IPFS approach. Broadly, I think there is some niceties to having Hypercore be a little bit less generic, because we're able to build network flows that are really nicely custom tailored to the Hypercore structure, so we can kind of focus on making sure that Hypercore logs transfer as efficiently as possible over the network. In practice, I don't want to stand too strongly against that, because I don't know what kind of optimizations the IPFS world has done, and it's entirely possible they've caught up to any kind of difference that would make. So it may not be, it is a little bit like SSB plus IPFS. It's very, very much like that. We don't do a linked list for the logs. We actually use a Merkle tree turned on its side, which is important for efficiency reasons. But yeah, so like IPFS is just a more generic approach. And so in a way, I think the code kind of reflects that. Hypercore is very modular, to be sure, and hopefully is going to be open to people doing lots of things. But generally, we kind of approach everything from a higher level. We don't, in a way, in my experience, whenever I look at IPFS, it feels a little bit more technical, a little bit more complicated than using the Hypercore tools. I am super biased, so and there's something incredibly elegant about the IPFS approach. So don't get me wrong, I think it's a pretty neat idea. So that's kind of my rundown of the Hyper versus IPFS world. It's not a super huge difference, to be frank. I say use whichever one you're feeling, It's just your vibe. Anyway, for my money, the best advantage we got in the Hypercore world is the team I get to work with. Matthias and Andrew Osh and all the people in the community. Carissa and Ranger and all those folks, that's our... Is that the worst, most generic response ever? It's the people that really differentiates us. But it's true. Okay, so where was I? Create, and we've created our structure. Okay, well, we need to actually create the internals. So, first things first. We should probably make sure that we're not accidentally calling create on something that's already instantiated, so... And Johan, of course, you're another one of our big advantages. Create on a... It's about the friends we made along the way. It's so true. All right, so that's that. And now we take a look. We just go ahead and copy. It's always about the people first. Okay, so probably should do some validation just to make sure we don't kill ourselves here. So if type does not equal hyperdrive and type, that's why we're not doing the crypto. Hey, if the crypto worked a little bit better, I might be using it, but it's just not there yet. The Ethereum 2 stuff is pretty interesting, though. I'm a hater, but I'm not that big of a hater, and moving to proof of stake, I'm interested. It's my biggest complaint with crypto, among many, but my biggest is the ecological impact of proof of work. I just can't, I can't do it, feel like too much of a jerk. But move to proof of stake, yeah, okay, that's interesting. All right, doing our validation here. So we set the type, and now we're gonna we're gonna react to the type if this dot type equals hyperdrive. Then I'm gonna do this dot API equals hyperdrive. I'm gonna copy some of this code here, and the big diff is we're putting a null instead of a key string. Else if this dot type equals hyper-b. You know what? We need to get that await. Wait for the ready. And then over here we grab this code. I'm going to need to check. We're going to need to check some docs. So let's pop open a tab, bring it over here, and let's see. Let's open up those Hyper-B docs, because I need to know how to create a new Hyper-B. Is feed optional? Should be a Hypercore, so I think we need to create a new Hypercore using the core store. Hyperspace client docs. And jump over to the core store, and get is, yep, okay, so similar to the Hyperdrive API, the core store API, we just need to instantiate the Hypercore separately, so we'll do that action there. And then we pass in that same core. Do I need to await that? I guess I don't. That's handy. Okay, so the same story, right? Create a new Hypercore for us. That Hypercore will be the backing for Hyper-B. And so now we should have this .api all set, which means we can do our final thing, which is grab the keister. And I need to check, where do I get the keister from? Where do I get the key from the various data structures? Okay, let me think. I've done this a couple times now, I should know. I think on let's see if I can find some code that I've done this on already. Oh, brother. Okay. Guess I'm gonna have to dive into some code. So here, do we have a .key attribute? We got a .feed attribute, which should have a key attribute. Okay, so in the Hyper-B case, it's going to be different from the Hyperdrive case. In the Hyper-B case, it's going to be this .api.feed .key.toString hex, which actually I could do differently. I could just do core, right? Because this .api.feed is going to be core. Sometimes we call hypercores feeds. Feed, log, same basic idea. So that one's that, and then I think on Hyperdrive, it's just going to be on the Hyperdrive API as key. Let's confirm that real quick. Yep. Okay. What? Let me check. If you don't pass in a key, I'm sure it's going to be right. Okay. So let's go ahead and assume it is. All right. So that's that action. I think we're ready. Let's find out. Ready. It's good to be doing streams again. I had to take such a long break. And that's looking promising. I think we just created a hyperdrive. Yeah, I think we did. Yeah. Yeah, we def did. Great. Okay, let's rename it because the key is Find test hyperdrive. Okay, so that's good news. So let's test out our hyperstructure stuff here. So we're gonna do var drive equals await hyperstruct.get. And let's try doing a await drive.readDir. There it is. Isn't that cool? It's really cool to be able to like have this kind of magical, you pass in an opaque cryptographic key and you get out a file drive or a database. That's a pretty neat little bit of work. I'm a fan. I think I'll stick with it. So, what's next? So the collection here is broken. That's interesting. Let's take a look and see why that's broken. All right, so that's our URL. We should also try testing whether or not I can create Hyper-Bs using my create function, but let's get to this first. Yeah, so it didn't save. Okay. Any errors? No errors showed, so something broke there. Let's not worry about that yet. Oh, you know, I know why that didn't work. Yeah. Changing so much. All right, so let's real quick test our Hyper-B creation. And I'm going to do that by doing my internal API uplink .hyperspace.create. And let's do something wrong first. I don't know what that is. Now let's do something right. Hyper-B. That's wrong. I have a typo. Aha, I do. That should say Hyper-B. I think I may be responsible for Hyper-Bs being called Hyper-B. If I knew we were going to be using Hyper-Bs like in everything moving forward, I would have helped come up with a better name. But Matthias jumped in the chat and said, hey, we need a name for this. And I said, I don't know, call it Hyper-B. It's a bee tree. It's cute to say Hyper-B, like a buzzing bee. And now it's called that. Now that's what we call it. I don't think I thought that through. What's your database system called? Hyper-B. Like the bug? Yeah. Okay, so we got a URL there. Let's check if I can access the API. API.get URL b dot. I think put. And the key encoding. I'm going to need a new text encoder. Don't try this at home. I'm going to encode foo, and at foo I'm going to put bar. And I need this to be JSON encoded. Okay, forgot to await that. Let's find out if it worked. It did work, except I didn't need to do the JSON encoding. Well, that's good. Good stuff. Our create function works for Hyper-Bs and hyperdrives. Browsing success. Okay. I'll just make sure this email I got isn't a big deal. Okay, we're looking good. That should be later. Okay, just gotta make sure nobody needs anything from me right now. And good, okay. Well, I'm gonna continue this minor pause to get myself another drink, so BRB. Alright, back in action. There's apparently a Diet Coke shortage in America. Does anybody know what's going on with this? I'm dead serious. You can't get Diet Coke. I'm doing the HEB generic brand, which I find to be totally fine, but now that's out of stock. This is what the pandemic has, this is the this is the cost of the pandemic, is that you can't get Diet Coke. Anybody knows what's going on there, hit me up in the chat. All right, so that's all set. So we got to create. Okay, so we need a little bit more here. The next thing we need to do is get this. I guess let's go ahead and commit this change, because that's a new piece of code. We want to get that committed, so we'll jump over to okay, we're going to go to work, uplink, and we're going to, I think that's just the create. Yep, okay. Add hyperspace create method. Okay, that's that. And now. Okay, so in the sidebar here, we have a UI that is basically your collections of hyperdrives that you've created or chosen to save. That is going to be using these Hyper-Bs as your database of saved drives, right? And right now, we're going to talk about this. You know, I'm going to have to sync up with the team on the best way to architect this, but at the moment it looks like we're going to have two kinds of Hyper-B databases that Uplink uses. The first one is the user database, which is what we're looking at here. This is the private database. It's similar to what Beaker uses with the private hyperdrive. It's where we're going to store our settings and where we're going to store basically private information. And so it will actually do double duty as both a collection holder of things that you create, hyperdrives you create, and also any other kind of application user data you need. But we also want to be able to have, if you look over in the nav here, you can see this little arrow right there that allows you to collapse and open the collections. So the idea with these collections is that other than the one that's your personal private collection, you'll be able to create a new network shareable collection. So that's the second kind of Hyper-B database we're going to use. And so you could create a bunch of hyperdrives, add in add them all into a collection, and then share that collection around. And the idea with that is that it's good for like a team, right? You know, I have mine, Matthias will have his, Andrew will have his. We put the URLs inside a collection, share that collection around. There you go. We got a little team sharing action going. So first thing we need to do is get it so that whenever I do new hyperdrive, it saves into the default collection, the kind of the user data one that we're staring at the data set of. And I think the first question is whether or not we want to have that hyperspace.create function, the one that we're looking at right here, whether or not that should automatically add to the database or if it should be a separate call. I'm going to go ahead and automatically add because this code is all internal. I don't need to worry. Thank goodness it is so nice to not be building an API platform for once, which with Beaker, everything I do that's a public API, I got to think about it like 10 times over. Here, I can just do whatever works for now. So I'm going to do what works for now and make it so that whenever you create something using the Hyperspace API, it automatically adds it to your collection. So let's get that going. Now the code I got for managing collections is over here. Inside of the Hyper folder, which contains all my Hyperspace code inside of Uplink, I've got this Hyper folder, and I got a DB's subfolder. And so these are all these sort of APIs for dealing with data that's stored inside of Hyper-Bs. For instance, here's the settings code right here, okay? And the way this works is we have the user database, which is this one right here. It gets loaded up at startup time, and then we just hold on to an instance of it, right? So there it is, getting loaded up in startup. And then we hold on to the key or to the object, and then we have this right here, get user DB. So then all my little database interfaces can ask for the user database to query it for information, like settings, for instance, which is just doing real simple: set, get all, some event handlers or event emitters rather. And so whenever I call set, I ask for the user database, and I put to the settings subspace whatever value. Pretty straightforward. Same with get, right? Okay, so with collections, it's a little more complicated because collections are not just the user's local database, it's also collections that you might create separately and share around. Somebody might give you one of these collections, and this is actually my next primary task. This is what I was sort of prepping for when I started to get all this generic Hyper-B management in here, was I needed to be able to load up the collections that people share and have them show up inside of Hyperspace. So if I create a collection over here, copy the URL, share it with somebody. When they load it up inside of Uplink, it needs to not give this interface, actually. What it needs to do is give an interface showing all the hyperdrives inside the collection. Be like, this is Paul's collection of hyperdrives, right? So this is actually too low level for what eventually we're going to want to have here, which is where this little type identifier comes into play. Like I said, I'm not totally sure that's what's going to be the answer in the long run. Getting some major index.json vibes on this one, but what can you do? Here's where we are. So, okay, 3 o'clock. I got a lightning talk I got to give, but I got 2 or 3 hours, so we're good on time. And I don't know how long y'all are feeling. As soon as the viewer count drops to 2, maybe I'll give up the ghost. But okay, so this is our collections code. The primary collection is the user database, so that's what we want to interact with. We want our hyperspace API, and we're going to do this. We're going to get the struct like so. And we will eventually return struct.url, but first we gotta save it in the collection. And so we're gonna call getPrimaryCollection, which we should be able to do off of hyper.dbs.collections.getPrimaryCollection. And then we get this API right here, and we just need to set. Now, I don't remember now what kind of information I'm supposed to set there. So let's take a look. Surely I've got this living somewhere. Yeah, okay. So set needs 2 things. It needs the key and it needs a title. Okay, I'm not going to worry too much about this. I'm going to do set. Oh, get out of here. Why did it just do that? Get out of here. Collection.set, and it's going to do struct dot the key that I want to. I can give it the URL, so I'm going to give it the struct.url, and then it's just going to be an empty object for now. Okay, it's acting like that's not a. Oh, I need to do it. Await, I think. Yeah, that's why it was bothering me before. Okay, so that's that. Okay. I have code living around in some other subsystem, which is designed to correctly set the metadata inside of all the collections that you own whenever the title of a hyperstructure changes. So we're going to trust in that code, see if it's still there banging around and doing what it's supposed to do. So let's rock. Okay. Why don't we go ahead and get that start page wired up too, since that's so much more convenient. It's right there, and it's in my face now, so I'm going to do it. So that's in userland, and start. Okay, good. It's already right. So click that button, and there it is. Hey, it's all working. All right, let's try changing the title. My test drive. Okay, it didn't update right away. So let's find out if it didn't update because my UI is not responsive, or if it didn't update because the metadata did not automatically update. Let's find out by looking at that primary database. See, now here's where getting the Hyper-B, yep, okay. Getting the Hyper-B viewer into the uplink was a good idea, because now I can debug my primary data store by loading it up. That's fun. And it looks like, as you can see here, here is where the collection items get stuck, and it is not updating right there. So we got a little work to do there. I think I remember now why that would be the case. No big deal. We'll get to that. Basically, inside of a collection, you need to store not just the keys of the hyper data structures in the collection. You need to store some metadata like the title of the thing, because, you know, when you share that collection with somebody, it needs to load up showing a listing with titles for each of the hyperdrives. You don't want to have to hit the network for every one of them to start to display that simple kind of metadata. So we got to denormalize our data a little bit, would be the good way to describe that. So that'll be probably a next task, would be to get the system back into the place where it notices whenever the title changes inside of one of your hyperdrives, and then writing that information into the collection. And I think what's happened is that I've lost the code which detects whenever the title changes because I rewrote all my APIs. We actually have a lot of things that have busted. I believe I can't even make a folder anymore. I can't. So why don't we do that next? Because that's kind of straightforward. That's kind of stuff we're going to be doing next. So first, let's go ahead and commit that little change. Or let's call it the primary collection. Okay. Now let's fix that mkdir. Why did it break? I did all this code, man, like, well, right before we released the new beaker is really what happened. And so it's all flown out of my brain. So on new folder, let's take a look at that code. So that should work, right? Oh, maybe it did work. It did work. Yeah. Now, the reason that didn't seem to work is I broke a different thing. It wasn't make mkdir that broke on that one. It was the, I used to have, and I need to restore, a change watcher. I had some code that was sitting there and watching for changes on the hyperdrive, and whenever the hyperdrive changed, it would automatically reload the folder. So it's nice and responsive. Good thing to have, and that was something that got lost in the API changes. Total bummer there. But I do know for sure that one piece that did get broken is file importing and exporting. Now, do I want to hit that next, or do I want to try to figure out why I can't load hyperdrives? Maybe let's get into that hyperdrive loading yet. And maybe we'll call this the last task we do on the stream. Yeah, because it's been over an hour here. It's probably about time to wrap up. So let's see, in the remaining time, if I can figure out why Uplink can't seem to load hyperdrives. Now, I have a theory, which is good, because if I didn't have a theory, I'd be really worried. Yeah, hopefully my theory is right. So let's try again real quick. Not working. So let's dive into some code. My theory is that I have forgotten to configure my hyperstructures to access the network. That's my theory. Pretty straightforward. It's a pretty likely theory too, I think. Because basically, if you look, in fact, it seems pretty likely that's the problem, because if you look inside the hyperstructure loading code here, you notice I got everything going on except for an important line which says, join the network. You kind of need that if you want to access the hyperdrives off the network. Now let's take a look real quick. I'm sure yeah, see, I don't even think yeah, it doesn't even look like I got that anywhere. Yeah, so that got lost. Rookie mistake. Rookie mistake. So to fix this, I'm going to open up real fast the beaker code. And I'm going to close out what I was doing there. Jump on up into beaker, and I'm pretty sure that somewhere inside of beaker, I got the code that I want to copy paste. So that's not actually, oh, you know what? I may not have the code that I want to copy paste. Yeah, because beaker is really a little bit outdated in the way it's interacting with the hyperspace daemons. So, shoot. Okay, in that case, here's a little hint about me. I avoid doing work whenever possible. If I can copy and paste the code instead of having to think about what I'm doing, I'll do that. Now that's interesting. Okay. Yeah. So I'm pretty sure that in the uplink code, I have a snippet that I need. So if I look through the commit log, I bet I can find pretty quick where I lost it. Probably somewhere around over here when I did that stuff originally. Let's take a look here. I appreciate that, Johan. I keep just enough in my brain, and I rely a whole lot on everybody else. I keep just enough. Okay. there was a brief period where we thought Uplink might be a social network, but we decided not to do that. So now it's a hyperspace explorer, and there's me changing the description accordingly. That's a story for another time. Where did could I take a commit and diff it against master? Let me think. Can I give you yes? Okay. I am sure that somewhere in the changes, I have the piece of code that I need, surely somewhere in here. Don't make me think anything but that. Wow, huh. Gosh, I wonder how this code got lost. Huh. All right, well, I'm going to do this another way. I'm going to jump over to the Hyperdrive daemon client code, which is a legacy piece of code now, and I think it should have what I'm looking for. There it is, right there. Network.configure. You pass in the D key, and then I bet that's over here. Client.network remote core store. Okay, and this probably has the configure function. I'll explain what I'm doing once I find what I'm looking for. Come on. Not here. Configure. In the options, I want to look up and I want to announce. Okay. This is what I was looking for. I was looking for the piece of code that the Hyperspace client exports that allows me to configure the swarming behavior, because that's what's missing, basically. What I have to do is tell the Hyperswarm system, hey, put this thing online, and I both want to look up and announce on pretty much everything. I probably don't, well, yeah, pretty much everything. We'll just do everything for now. You might not want to necessarily announce the user database, but actually you may want to at some point. We'll just go with yes. And I just want to make sure, I'm really kind of surprised that there's code isn't anywhere inside of Uplink right now, but I guess it's not. Don't know how I lost that, but I did. And so I'm going to stick that, where am I going to stick that? I'm going to stick that both inside of create and get. I'm just going to do a config network. Probably no need to do the reuse like this, but it's a good way to make sure I don't screw it up somehow. And config network is just going to do get client.network.configure. And it needs the discovery key or the Hypercore and the options. Probably the easiest thing to do would be to pass in the Hypercore, which maybe I need to make a getter for this dot core, yeah, and then it's going to be lookup true and announce true. So the difference there is when you're doing lookup true, you're asking the DHT, does anybody have this thing, right? Obvious step number one. If you're doing announce, you're saying, I might have data on this, you should connect to me for it. I'm not necessarily sure I should be doing announce true all the time, but it's not a bad idea. I'll have to bug Matthias at some point about whether or not that's the ideal. So, not type, this is the core, and I would want to do some type-specific loading here. If not, this.api, return undefined, and this is exactly like this action was over here. This.api.feed versus this.api. Yeah, and I believe it's going to be if this.type equals hyperdrive return this.api. I want to say metadata. Pretty sure that's what that is. And then on Hyper-B, it's this.api.feed. 99% sure about that. Let's just put in a little console.log here to make sure. Okay. I think that will give us everything we need. Okay, now that's interesting. I would have expected that to get hit. Maybe I'm probably not using hyperstructure code for the database. I'm probably loading that directly. I am. That's fine. I don't necessarily want the user database on the network right now. Maybe in the future whenever you're syncing up devices, but at the moment, no. Now let's see. Yes, hyperdrive worked correctly. And then why don't we test by creating a Hyper-B again. And it added as it should, and I should go to it, and it should open up as a database. Sweet. Man, that feels good. Okay, and now they're both working, which means I think we can finally get the demo I was trying to do at the beginning of the stream. Everybody hold your breath. Ha! Total failure. Interesting. Except, that's interesting. 7, it didn't even hit the code it was supposed to. Why not? I should be seeing an entry in here, because this was the hyperdrive that I loaded. This is the Hyper-B that I created. And we should now be seeing an entry for this one right here, the key starting with 560. But it's not showing up. Now, why would that be? I call this .config network in both of those cases. Oh, ha, yeah. I need to call config network earlier. I need to call it right here. Because if I don't config the network there, then I'm not going to be able to get the first block. And if I can't get the first block, I can't detect what kind of device we're dealing with. Interesting. Which means I probably don't want to reuse like this. I probably might want to deconfig here. Let's do this, dude. Something to ask Matthias, do I need to unconfigure at that point? And then on create, we're going to do it there, but on lookup, on read, we got to do it right here. Because we need to get onto the network so that we can do the initial detection. Let's give it another shot. See if it fixed it. All I'm trying to do is load up Andrew Osheroff's hypersite. That's all I want. Oh, I forgot to remove. You know, I want to have this big moment, and when knucklehead stuff is what fails me. That's just disappointing. It's fun because, you know, I'm bummed that I didn't get this part working for everybody else because you get to see the little bandwidth indicator. Yeah, there it is. Okay, and check it out down here. You can see our bandwidth usage, so you can see I'm downloading not very much because it's actually just metadata we're pulling down. See these little spinners where it's sitting there calculating how many bytes is in each folder and what the download state is on each of them. So if I go over here and right-click and download, watch this little spinner. Boom, downloaded, right? 100% downloaded. We should see a little bandwidth spike there. All right, let's do that again on a bigger one. 4 megs. All right, so it's at 0% downloaded. I'm gonna hit the download button. Now watch that little guy go, and then watch over here. So it's trying. Oh, we may not be able to get. It may just not work. It's entirely possible there's not a peer hosting all the data that we want. So that may just fail. Let's try another one. Let's try like this. Come on, buddy. Oh, there it goes, and there's that little bump. The crowd goes wild indeed. This is pretty cool. I mean, I'm pretty stoked on where this is all headed here. Let's try and open this. All right, so this is a known thing where it gives up too quickly. But no, actually, in this case, it looks like maybe nobody. Surely somebody has his thumb somewhere. It's entirely possible. See, this is one of the tricks of a peer-to-peer system is that if everybody's sparsely downloading pieces, you could have 8 connections and not a single one of them might have one of the individual files. But that's surprising, because that's on his start page, so you would think that somebody would have the thumb. I'm going to try explicitly asking for it. And now it works. Except it didn't. Wonder if that's just another bug. That might just be another bug. Yeah, that is another bug. Okay. No bigs. The iMage. Okay, well, I'm still calling that a victory. That's an interesting new bug to deal with, is this failing. There's nothing wrong with that. I mentioned earlier that we have this little hack of using a... Well, you know what? This isn't so hard. It's just not passing in the URL correctly, so it might just take half a second to fix. Why don't we try to fix it? That's going to be over here somewhere. It's going to be in the file display code. And how is it picking that? This.info.url. Is info not set? Let's find out. Let's do a little console.log of this.info. Interesting. Okay. URL used to be there. Okay, that's interesting. So let's wind up the stack here. So here's the view that uses it. Yeah. A little surprised, to be honest, but let's... Surprised based on some of the code that used to be there, but okay. Okay. I think we're in business a little bit. We're in more business than before. The URL is correct, but now it's being real slow to load. Boom, because we have a bug there. All right. We're fixing it. Said we were going to do one more thing. We're doing two things. We're fixing the file display code, which there's a local HTTP server right here. And it's calling stat, and it can't call stat. Can't call stat because it's not struct, it's struct.api. So I need to fix all of those references. So that's 1, and that's 2, and that's 3. Struct dot. Make sure we got them all. Struct.type is correct. Struct.version. Okay. Let's reload and see if we can get that image. So we'll load up and we will go to the thumb. Oh, still not working. Callback is not a function. I think I know why. It needs to be API to promises. This is a little quirk of the Hyperdrive API. For backwards compatibility reasons, the promises API is on a sub-object called promises, which is kind of a bummer. And we only need to do it there because these are stream functions. We don't need to promisify versions of them. It's fine. That was the best choice we could make to maintain backwards compatibility, but unfortunately, there's a couple of places where I miss it like that. All right, let's try one more time. Hey, there he is. And now the crowd really goes wild. And that's it. I think that's some solid stream progress. So we're gonna first fix that, not you. I'm gonna need to remove that log. Okay. Fix reference. Okay, and then we're gonna do okay, and finally we're going to check out that. So remove it, and that's that. All right. Well, thank you all so much for joining me. If anybody has any final questions or anything, now's your chance. I'll give you a solid 5 minutes before I wrap up the stream here. But by and large, we're winding this guy down. Stream number 1. I'm hopefully going to get back into the routine of doing these things. Tell your friends about the Patreon. If there's anything that y'all want out of these streams, out of our Patreon, or anything like that, let us know. We're looking for ways that we can make this fun for everybody and make some interesting content along the way as we're building this stuff. It's all part of our new strategy to be interesting. So that's the action, and really, really excited to... Oh, you know, one other thing is that later this evening, there's going to be a decentralized web meetup that the Internet Archive is putting on. If you check my Twitter feed, you can find a link to that. And I'm going to be giving a lightning talk there about Beaker. So there's going to be a lot of other projects there. A lot of projects. They've collected like everybody to do a bunch of lightning talks. So it's going to be a good time. I would recommend checking it out. And I guess we'll call that a wrap here. I'm not seeing anything else. I don't know how bad my delay is here, so I don't know if folks are just now hearing me say I'm running down or where we're at here. But super good to see you again, Johan, and Philip back when he was on, and Carissa. It's going to be good to get back into the routine of this. Hopefully our workload, we went heads down for that 6 to 9 month period with the Beaker 1.0, and I had to kind of cut off all these things because we were trying stuff and throwing them away. I wasn't ready to show it. We're now much more on a direct path, so I can do these streams more. That'll be fun. Looking forward to it. Jerry, you're asking, don't you have a feeling like rebuilding the internet as into the same way it's currently working? Could you elaborate on that a little bit? Don't you have a feeling like rebuilding the internet as into the same way it's currently working? Like, are you asking... share alias. Oh, yeah, I could do that. My alias is .file. Where do I even have that? I'm guessing that's in, like... Jerry, tell me what you're... Give that to me again. What exactly are you asking from me there? Asking me there. In the meantime, I'm gonna try to find those aliases. Where do I have this? Is it like a bash RC? No. Huh. I don't understand how Linux works. Oh, there it is. Right there. Pretty simple stuff. Well, just dump it into the chat. Boom. There you go. I'll leave that to you to parse out. Yeah. Jerry, why don't you, I don't know, hit me up on the next one. Because I gotta wrap this thing up. But yeah, next stream or online or wherever, just hit me up, ask me that question again. I'd be happy to dig into it. Thank you all so much for joining me. I'm super psyched to be doing this again. I really am. 10 seconds, noted. Great. I'll talk to you on Twitter. Okay, y'all have a great rest of your day. I hope I'll see you at the Lightning Talks later this evening. And if not, I'll see you at the next one of these streams. So have a great rest of your day, and I'll see you online. Later.